Go ahead.
All right, welcome back, EL 140 Residential. We're going to be covering West Covina here, Mr. Sanchez. We're going to be covering Unit 4, Meeting 1, smoke detector circuits, describing the characteristics, functions of various fire alarm systems and components as it relates to these smoke detectors, describing the interconnected circuit requirement of smoke detectors in residential applications. So again, like I mentioned before in many of my videos and exercises, always start off with the NEC, going over the compliance issues. The NEC describing the interconnected circuit. It has to be a hardwired system. I explained to a lot of my students through past experiences with inspectors, looking at their sheets, looking at their inspection sheets, the number one box on top of every inspector's list is the smoke detector circuit. Whether it's a plumbing job that they're inspecting or some carpentry job they're inspecting, the first thing on every list of inspection is a smoke detector circuit check. So that describes the importance that it should have and their understanding, because it's going to be something that's going to become an issue where they're going to have to maybe implement that on top of the project or permitted project that they're working on. So in describing the lab exercise, one of the first things that I pull out for students, I always give my students time to review things on their own first, to digest things. I'll have them read this instruction sheet, and there's invaluable information in here about where we can install it, where it should be implemented, based on the manufacturer's specifications, recommendations. Make sure you're giving this sheet to them to review. And then I go over with them personally, breaking down all the components of something maybe they didn't understand, especially trade terms, right? The language of electricity, they're not all up to par. So that's where we come in, the interpreters. So here I got the simple circuit drawn out, got 3 smoke detectors. I got my first incoming line, which should be what? Again, we're gonna have that dedicated circuit breaker, bringing in that 14.2 cable. 14.2 cable, I'm going to use that non-metallic. I'm going to be using a 14.2 cable, bringing in power into that first smoke detector from the main circuit breaker that's dedicated to that. That one's going to be specifically labeled. I have seen in some installations where you can actually purchase a circuit breaker that is red in color. And it's specifically designed just for smoke detector fire systems. But other than that, a label works fine as well. You have your 14.2, your hot, your neutral grounded conductor, your ungrounded hot, your grounding coming in. Then in between our smoke detector circuits, we have 14.3 starting at this point. And cabling. Why? Because we need that traveler conductor that's going to interconnect. So I usually use the red conductor within that 14.3 cable as that traveler that interconnects all smoke detectors together. And as we all should know already, if one alarm goes off, they all go off through that interconnected ability of that system. It's an easy wire management project for students, but I think we should take it more in depth, taking it back to the NEC, taking it back to the manufacturer's spec sheet there, and all the background information that they give you on top of that. So it's just like a 1, 2, 3 combination as far as our typical wiring of conductors. The only thing new to it is providing that interconnected circuit between all the smoke detectors and explaining that concept. Here on the board, you can see we got 3 smoke detector circuits. In between here, we got the 14.3, we got the 14.2, we got our source box, our junction box, where we have our source power coming in today. One thing that a lot of the inspectors, on top of the NEC, my experience with inspectors from different authorities having jurisdiction, AHJs, is some will be specific, and they'll tell you, like in their sheets that they give out to you sometimes, they want the front door replacement battery concept. But like we know, most days now, when you go buy them in the store, they got the sealed batteries. So we want to explain both concepts. And most of those sealed batteries are 10-year warranties as far as lifespan on that sealed battery that doesn't have to be replaced. We're going to replace the whole unit. But is that telling me that I should just come back every 10 years, or telling the customer that they should have it only replaced every 10 years? No, that is dependent. So this is another experience teaching lesson, is that is dependent on the household. Do they cook every day? If they're cooking every day or on a regular basis, just like walls, they get covered in silt from oils and smoke and cooking. So do the detectors. Therefore, the detectors are not going to operate at an optimal level. So the simple test is if the outside surface of the smoke detector is impacted by that grease or dirty air quality, then that's a sign that the smoke detector should be replaced, even though the battery might be in good working order. So all we're doing is bringing that ungrounded, grounded neutral, the grounding, and putting it into the interconnected plug-in circuit that is provided from the manufacturer. We got that plug-in cap with the power leads coming in. So that's one of the reasons why they don't want a battery that's going to be replaced from behind the scene. They want it so that customers, people that are non-electrician, can just come in, replace a battery annually. But if it's a sealed battery that has a 10-year, that's the other option. One of the other things that I point out to them is a lot of times when you get a service call and you hear that somebody saying, oh, it's chirping. Sometimes it's the battery. Sometimes it's like this one. It looks like it has a little malfunction with the battery door not closing completely. So sometimes the contact's not making contact can be a point of chirping. One of the other things I bring to their attention is smoke detectors. Some have photoelectric sensors. Some have ionization sensors. Some authorities having jurisdiction will require that you have both. And we got to explain to them what is the difference. The ionization versus the photoelectric, explaining the difference between the sensitivity levels. And the Zoom and the PDFs do a great job of that. Especially when we get into 160 and we start working with the commercial systems, it explains all that very much in detail as well. So keep that in mind. Some cities will require one or the other, or they might require a combination that they have the photoelectric and ionization. You have to determine what that authority having jurisdiction. As we come in between, we got that 14.3. The only reason we changed cabling systems here with an extra current carrying conductor is so that we can have that interconnected red wire that's going to go from this first detector to the second detector to the last detector in the circuit. One of the other things that people should expect is anytime that the circuit is de-energized, meaning we lost power to our circuit, the alarm system should alarm. It should alarm. And that's a manufacturer kind of detail that usually happens. Let's try it out. Let's see if it happens. Okay, we didn't get it, right? We just cut off power here. We didn't get the alarm. But that's a manufacturer detail. I just did one not too long ago for a neighbor of mine. And every time she's got the sealed battery type, we have the front door loading type. But the sealed type automatically goes into a short alarm burst every time the power goes out to the circuit. Or at this one, the one thing that I noticed when we hit the switch is it chirped. And the same thing when we provided it power, it chirped again. And you can hear a chirp here and there. And again, that's going to be the battery, because these might have been sitting around on the shelf. And guess what? A lot of people come in here, what's that chirping sound? And I'm like, it's the smoke detector sitting up on the shelf waiting for that one day we're going to bring them back out again. But right there until then, they got the smoke detector battery powering them still, so it's always notifying us.
Would you mind to open this?
So we have the one in the middle of the circuit. Here's our traveler that interconnects the system. There's still our power source coming in, and here is our grounded neutral, taking it all back just like any circuit. Incoming power, outgoing back to source, returning. But just remember that these are essential. Oh, one last detail that's very important, especially for the construction field as we're installing these, and there might be other work going on. Keep the little plastic covers. They look like little shower caps, right? Keep those plastic covers. Once these have been installed, put the plastic cover back on. Make sure it's clean. Make sure you're not leaving fingerprints. And because that's obviously because of the dust and the other byproducts of construction sites, okay? So we'll see you in lab again on the next project. Thank you.